no independent constant term, no independent constant term or constant independent term, no constant independent term. Okay, independent constant term or constant independent term doesn't matter. No separate independent term which is constant, because every term is involving variables x and y. This is what you call the curve is passing through the origin. So it is passing through the origin. Third point, what we do, then we put, because the curve is okay, because at x equal to a by 0, now let us, we cannot replace now y equal to 0, we cannot put here, because then everything is 0. Because x is 0, if I put y 0, x will also be 0. Origin is there, or there is no shifting of origin here. Only from this equation, smallest degree term is this, so replacing, putting or equating. Let me take here 0, 0 is the only origin, so no shifting of the origin. Okay, so if I solve it for them x and y, you just put, so equating the coefficient of if I put y equal to x here, then what is the equation? Let me check that, what is the value of x then. So equating the coefficients of smallest degree term, equating the smallest degree term 0, the smallest degree term to 0, x into y equal to 0, x equal to 0 and y equal to 0, we get. So we get x y equal to 0 or x equal to 0 and y equal to 0. There are two distinct tangents here. Tangents are there, but they are distinct tangents. So node type of curve will be there. So it will be there will be a node here. What the value of a node? Let me find out that. If I replace, as I put x equal to y, let me take y equal to x, because this is passing through that, or it is lying on that line. So if I put y equal to x in the given equation, let me find out. Put y equal to x or putting y equal to x in the given equation. In the given equation, we get is x cube, that means 2x cube is equal to 3 ax square. So let me take this to this side. Be x common, x square common, be twice x minus 3a. X equal to 3 upon 2 here, 0. So this implies that x equal to 0 and x equal to 3a upon 2. X equal to 3 upon 2. X equal to 3 upon 2 is one of the points at which the curve will intersect the line y equal to x. But y equal to x, the point is this x equal to 3 by 2. Now if I substitute x equal to 3 by 2 in the given equation, then x equal to 3 by 2 here, then y can be calculated. With that y, then let me find out value of y then. Or similarly, if I replace y by x, then y will also be obtained in the same way. So y will also be value 3a by 2. So this is the point, because y equal to x here, the line, x is 3a by 2, so y will also be 3a by 2. Okay, from the given equation. The point is 3a by 2 and 3a by 2. At this point, the curve is intersecting. Okay, and beyond this, the curve will not go. Why? Because after that, if I solve this equation for y, okay, or x here, we can solve this equation for y, and beyond that equation we will not get. Let me, okay, before drawing, let me check whether the curve will exist beyond this point or not. That let me check here. Then the curve will be drawn. This will have to trace the curve. Before that, let me find out the equation, solving equation. So this is y, if I take common, y square minus 3ax, okay, or y cube, y square minus 3x equal to minus x cube. Okay, so, or if I equate the coefficient, so x equal to 0 and y equal to 0, okay, those were the only tangent line. That means at x equal to 0, the equation was y was also 0. Because from this y independently cannot be calculated. Y is equal to 3x and x is negative. Oh, sorry, y is equal to 3x. And but this equation is also there. So y equal to, if I find out no, it cannot be calculated here, or only x and y are there. What is the solution of this equation? Let me check it. As I told you that there is a curve which is along the line y equal to x, or symmetric to the line y equal to x. Okay, now at this point, 3a positive value 3a by 2. Let me take this is 3a by 2. At this point there is 3a by 2. The curve is passing through the origin also. Okay, passing through the origin, this is 0, 0 point. This is O, x axis, x dash, this is y and y dash axis. Now, what is the asymptote here? Now, if I find out y equal to x, as I told you, that there is an oblique y equal to minus, y equal to x is there. This is oblique, okay, here it is. I'm sorry. And this is the curve here. It will meet the curve at, I'm sorry, this is because x equals 0 and y, I'm sorry. The curve will be x-axis and y-axis. Okay, x-axis and y-axis are the, because x equal to 0 and y equal to 0 are the two tangents. Okay, we have to draw the tangent like this. Along the x-axis, there is a curve. Along the y-axis, this curve will be there. Okay, so now if I take a line where this will meet, this oblique, this is not oblique asymptote. There is no proper asymptote, but oblique asymptote is there. There will be an asymptote which is oblique asymptote, because no, along the x-axis the tangent line is not there, but this oblique okay, asymptote is there, which intersect the lines x-axis and y-axis at these two points. So these points can be calculated, but the tangents at this point are x-axis and y-axis. X-axis is the tangent to this curve, as say x equal to 0, and y equal to 0 is this. This is x equal to 0 on the y-axis. Y, that means y-axis is the, here it is y-axis is the tangent line, or the asymptotes here, and this y-axis, x-axis, y equal to 0 is on the x-axis, so y 0 is this. So this kind of curve will be there. Okay, and if I take this y equal to x to line further, this is an oblique asymptote we say. So 3a by 2 is the point, and beyond that the curve will not exist. So then y will be negative, or the points will be negative of x and y both. The curve will not exist beyond this line. At this line, the oblique point is the same oblique point. If I take x equal to from this equation, we can find that this line is parallel to the y equal to minus x line. It's y equal to minus x line, which is this y equal to minus x line. This line is parallel to y equal to minus x. Okay, because this through this point y equal to minus x will be the line. So the tangent at this point 3a by 2 and 3a by 2, this line will be parallel to the crossing line, which is y equal to minus x line, y equal to x here. Oblique asymptotes are there. So no asymptote, but x plus y plus a equal to 0. Here x plus y plus a, the asymptote is x plus y plus a or equal to minus a. This, after differentiating this, we can obtain. So if I find the differentiation, but d by dx, let me find out that what is the tangent line here. This tangent line at this point will d by dx. If I find out at this equation, because in this case we cannot find out this point. This will be 135 degree. Region is d by dx will be negative. Then let me find out d by dx. So this is 3 into y square d by dx plus this is 3x square. Here it is in multiplication. Equal to 3a common. First is x, it is x as it is d by dx, and plus y as it is, x is 1. If I take d by dx and then equate to 0, what is the value of d by dx here? So these two terms are there in case of d by dx. So we can have 3y square d by dx minus sign, this is 3a x into d by dx is equal to 3ay minus 3x square. Okay, so if I divide by 3a, so this d by dx, if I take common, so d by dx will be equal to 3a cancelled out, this is a by minus x square divided by, so d by dx value for tangent at this point we have to find out. So d by dx, what is the slope of this tangent on this point d by dx? At this point, if I apply this a by minus x square divided by y square, because 3 is cancelled out throughout. So this is y square minus ax minus ax. If I substitute the value, this 3a by 2 at this point, what the value of d by dx? Let me find out that d by dx. Let me take here. This is d by dx at the point 3a by 2 and 3a by 2 will give us a into 3a by 2 minus 9a square upon 4, so 3a by 2 whole square, x square is divided by, in the denominator we will have y square, that means 9a square upon 4 minus sign. This is a into 3a by 2, x is 3 by 2. Now if I take minus sign common in the denominator, so that will be cancelled, or in the numerator. If I take minus sign common, the same value will be obtained, that 3a 9a square upon 4 minus 3a square upon 2, the same value divided by 9a square upon 4 minus 3a square upon 2, the same value, this is minus 1 here. d by dx is minus 1, that means d by dx is equal to minus 1, that means tan of 135 degree, negative value. Theta is equal to, slope is here 35 degree, m is equal to, or slope is, slope of the tangent at this point is 135 degree with the axis of x. Okay, is 135 degree. Theta equal to, or let me take tangent of that angle. Theta is, or slope is, m is equal to tan theta, which is tan 135 degree. Angle theta is, this theta angle is 135 degrees, because minus 1 comes out to be minus 1 value. Slope of the tangent at this point, 3a/2 and this. So we have just calculated that this curve is okay, or this nodal type of curve is intersecting the line y equal to x, where the tangent is making angle 135 degrees with the axis of x. This axis of x is 135 degree angle is making. Okay. This is something about this tangent here. So we have just calculated d by dx slope. If we have to find out of the tangent line, then we can find out this. This point is also because this slope is also having 135 degree. This is also 135 degree. This line is because it is parallel to this line. Okay, so this asymptote, which is x plus y plus a equal to 0. Sorry, x plus y plus a. This is oblique asymptote. This is equation of the asymptote here. This is the equation of the asymptote here, oblique asymptote. Okay, so this is the oblique asymptote. If I find out double derivative, then equal to 0, whether point of inflection is there or not. Double derivative of this point, then calculate. We will get next point here, d by dx double derivative. Okay, so if I equate that to 0, but no asymptotes, or you know point of inflection is there here. This point of inflection. So this is something about tangent is lying at 135 degree. Okay, that is how we have calculated this point. Now let me take next question, question number 4 here. Question number 4 now. Question number 4, let me talk about. Question number 4 here. Okay, question number 4 is question number 4. Trace the curve. Okay. Now in this case, a4 y square equal to a square x4 minus x6. Okay. This is question number 4 here. It says a4 curve is a4 y square equal to a square x4 minus x6. x6 if I neglect, then y is equal to, okay, and if I express this in y terms, neglecting x6, then what is the, so this equation will be a4 or y square will be equal to then plus minus x square or a into x square. So this will be x square upon a square, that is the value of y square, because x6 if I neglect, then we can find out value of y square in that way. So what is this equation now? Because each term is, so the curve is symmetric to both the axes here. Here the curve is first one, symmetry, let me talk about it. The curve is symmetric to both axes. Is symmetric about both the axes. Why? Because x is also even forward, y is also even forward. Both the axes. Both the axes. Second point, is it passing through the origin? Yes, it is passing through the origin. It is passing through the origin. Passing through the origin. It is passing through the origin here. Third point, because it is symmetric to both the axes, so sometimes we put x equal 0, y equal 0, let me find out what are the points there. Okay, and then solving this equation, or we can find out some points that where the curve is intersecting other than origin. Other than origin, at what point x is intersecting. Let us talk about it. Okay, so if I take here or equate y square equal 0, Okay, so y square equal to 0, neglecting this point, x equal to plus minus x square. Here, we put y equal to 0 first, then what is x value? So let me find out that value. Putting y equal to 0, let me check whether it is intersect the axis or not. Putting y equal to 0, so we get this, it will be ax4 minus x6 equal to 0. For x4, if I take common, it will be a minus x square. A minus x square equal to 0. Coefficient of y is 0, so this will be a square into x4 minus 6. x4 are taken common. It means x equal to 0, the curve here, and x equal to plus minus under root a. Is it a? Sorry, it is a square. Sorry, it is a square. A square is plus minus b on curve. This is plus minus a. I'm sorry, a square here. So this is a square. x4 minus x6 is obtained. So x equal to plus minus a. That means the point, the curve is meeting the x-axis at a0 and minus a0. 0, 0 is also there. X is also 0. 0, 0. The curve is meeting the x-axis at 0, 0, a0 minus a0. Now beyond that, if I find out value of y square will be what? Y square equal to solving the equation here. Or if I shift the curve to one point, let me shift the curve to a0 and then to minus a0. In that way, one of the points let me shift. Shifting the origin to one of the points. First one of the points led to a0, first a0, let me take. Then similarly we will have the same kind of minus a0, that will also be shifting. So what is the point there? Then it will be converted to this equation number 1. So equation 1 will be converted to or changed to the following: a4 into y square, it is y square only, equal to a square into x4 is there, it is a plus x or x plus a whole 4 minus this is x plus a whole 6. No need of even neglecting x6 because x6 is not required here. So what do we see? From this we can obtain x equal to, because from this x6 independent term will be there twice x. From this we will obtain whole 4. Whole 4 are taken. Okay. Y square equating the smallest degree term to 0. Y equal to 0 here. That means x-axis is the x equal to 0. Why? Because independent term here will be constant term. A is a square into x4 plus something twice x square, and here also x6 3x square. So smallest degree term will be from this will be x square, because it is x4 plus this, and x into the smallest degree term. There are 5 terms here. x5, x will be here, x will be 0. So it's equating the smallest degree term. Even we can neglect this, and only from this we can solve it. So equating the smallest degree term, to 0. We will have from this equation or that also that there will be one x power only, because this is 4 times, so 5 terms will be there, in which x cube will be there, x square will be there, and x4. Okay, so 4 times by binomial method will be open. We will have single term value also. So x equal to 0, there will be x equal to 0 means the new y-axis with the tangent, new y-axis will be the tangent to the point or to the curve at the point A0. The curve at point A0. It means curve is intersecting at this point, meeting the origin. What kind of curve will be there, then let me draw that curve. So finally the curve will be, this is A0 minus A0 point, here is A0 point. Beyond that curve will not lie, so we have to say this is the curve here. Here this is x equal to, okay, x equal to minus a here, x equal to minus a, and here it is x equal to plus a. But at this line, this y-axis is the tangent line. Okay, along this y-axis, which is parallel to the y-axis, this is the x-axis, and this x-axis. Okay, this kind of curve will be there. So the curve, this curve is meeting the x-axis at 0, 0, origin at 0, 0 point, a0 and minus a0. There are 3 points at which the curve is meeting the axis of x. Okay, now beyond these points, the curve is not going. The reason is the curve will not exist. Y square will be negative for that, because if I take x more than minus a plus a, then it is x6 or x minus a, this value will be greater than this. So this minus a, even number will be there, but it is with negative sign. So the term will be negative then. Okay, but up to minus a, it will be positive. But since it is a6 here, it will be 0. That situation y equal to 0. But beyond that, if I take more than minus a, then this value will be negative, so y square will be negative. Beyond this, the curve will not exist. Similarly here, a, if I put positive a also, then this is a6 minus a6 is 0. So, but at this point y is 0. But beyond that, if I take x2a or something, then this value will be greater, so negative term will be greater. So y square will, let me take y square will be negative for x greater than less than minus a and x greater than plus a. For these two values, the y square will be negative. Curve will not exist beyond these 2 points. Curve will not exist. The curve will not exist beyond these points, because otherwise the y square value will be negative. Okay, curve will not exist beyond this, because if I take here 2a, this will be 2a whole power 6, or even more than a. But up to this a, it will be a square minus a square 0, y is 0. Okay, and beyond that it will be a negative value, y square will be negative in this case also. So beyond these 2 points, curve will not exist. Alright, so this is, so the curve will not exist beyond these 2 points. These 2 points here. These points, or let me take these points here. If that is x equal to, x is less than minus a, cannot be. It cannot be. For x less than minus a will not have, y is going to be negative for x less than minus a, and x greater than a. Simple. Beyond that, curve will not exist. This is the type of curve here. Okay, so tracing of curve, question number 4 we have done. Let me talk about 5th question. This is question number 4th we have done. Now question number 5th here. What is question number 5th say? That we'll talk about. Question number 5th. Trace the curve y square into a square plus x square is equal to x square into a square minus x square. A square minus x square, or x square into a square plus y square is equal to a square into x square minus y square. Now these two shapes will be similar, so that's why I've taken one of the curves are solved, and then same procedure will be of that, and curves will be similar type solution here. Now in this case, x square even, y square is even. The curve will be symmetric to both the axes. First one, curve will be symmetric about both the axes. Will be symmetric about both the axes. About both the axes. Second point, there is no independent curve will pass through the origin. Curve will pass through the origin as there is no constant independent term. Constant independent term. Or independent. Sorry, what I'm writing here. This is independent term. Constant independent term is not there in both the equations, so they will pass through the origin. Third point. Now, if I find out value of y square, or if I put y0, x0, then we can find out from this x equal to plus minus a. Okay, and if x0, then from this x equal to x is not x is imaginary in that situation. So putting y equal to 0, okay, putting y equal to 0, we get x square into a square minus x square equal to 0, x equal to 0, x equal to plus minus a. The points are 0, 0, a0 minus a0. Yes.